Hi everybody, welcome back to this course on internet technologies. I'm Vardan and today we'll be studying about electronic mail and simple mail transfer protocol. Electronic mail remains one of the most universally adopted applications on the internet today, used by billions of people globally. To manage this communication, different protocols handle different aspects. SMTP or Simple Mail Transfer Protocol handles the sending part. So it handles sending the emails. MIME helps attach multimedia content like images and videos to these messages. On the receiving end, users typically rely on either POP3 or IMAP to download or manage their incoming mail. While we're focusing on SMTP today, it's important to see it as a part of this broader ecosystem. SMTP is quite straightforward in its operation. It was first originally designed to handle simple 7-bit ASCII text messages. When sending mail, SMTP only looks at the envelope information. Think of it like a postal service. It reads the address written on the top of the envelope but doesn't open the letter to see what's inside. So the message itself is divided into a header which contains details like the sender, recipient, subject and other metadata, and a body which carries the actual content. This separation helps mail systems process and route messages very efficiently. So here's a simplified diagram of how email delivery works using SMTP. A user agent like your email client creates the email. The message is placed in a queue if it can't be sent immediately. And the SMTP server listening on port 25 picks up this message. It establishes a connection with the recipient's SMTP server, and finally the message is placed in the recipient's mailbox for retrieval. This process involves multiple servers and protocols behind the scenes, even though it seems very instantaneous to the user. So when you hit send on your email, the message is created by your user agent, that is your mail client. And if your client doesn't directly run an SMTP program, it would forward the message to the nearest SMTP server. And the message includes an envelope holding sender and recipient details and a body containing the message text. Interestingly, the user agent extracts a list of recipients from the header to speed up the delivery process. This separation of envelope and content improves routing efficiency across networks. The SMTP sender program on the server picks message from its queue and opens a TCP connection on port 25 to the target SMTP server. And if there are multiple messages for the same direction, it might use a single connection to send them. Once the message reaches its destination successfully and the server confirms, the message is deleted from the sending queue. This process helps maintain server efficiency and ensures no redundant copies are left behind. And SMTP protocol isn't wasteful. If you're sending a mail to alice at gmail.com and bob at gmail.com, your mail server doesn't open two connections. Instead, it sends one message to gmail.com. The recipient list is handled by the destination server. Similarly, if you're sending multiple emails to the same host, SMTP may use a single TCP connection for them all, further reducing network overhead. These optimizations make email delivery faster and more bandwidth efficient. And of course, things don't always go smoothly. Some possible issues include the destination host being unreachable, or an email address being invalid, or the recipient having changed their address. And SMTP employs a retry mechanism. If a mail can't be delivered immediately, it's reattempted after a delay, often several times before being considered undeliverable. So SMTP uses TCP, which is a reliable protocol, ensuring data arrives in order and without corruption. However, SMTP's reliability stops at the recipient's mail server. It does not guarantee that the message will reach the intended user or that you will be notified if a delivery fails. Unless you receive a bounce message from the recipient's mail server, you're left assuming it was delivered successfully. Now, on the receiving side, the SMTP server first verifies whether the recipient is local. If yes, it places the mail in their mailbox. And if not, it may forward the message to another SMTP server closer to the destination. Additionally, it validates the recipient address, it checks for available mailbox space, and it performs a checksum to verify message integrity. And if any of these checks fail, the message is either returned or discarded. SMTP communication involves a series of command response exchanges. The sender sends commands like hello to initiate, mail from to declare sender, RCPT to declare recipient. For each command, the server replies with a 3-digit status code where the first digit indicates the general type of response. Any code starting with 2 means positive completion. The request was successfully processed. Codes starting with 3 indicate a positive intermediate reply. That means the command was accepted, but more information is needed. A code starting with 4 represents a temporary error. The client should retry later. And a code starting with 5 signals a permanent error like an invalid recipient or command. This structured messaging ensures smooth and reliable communication between servers. So that marks the end of this video, and in the next lesson we'll learn more about electronic mail and about protocols for receiving mail. So thank you for joining in, and I'll see you next time.